Okay, so this is the Mystic Circuits, formerly Circuit Shaman's VERT module. It's a digital binary counter. So simply, to show you how this works, we've got an input level at the top, which is currently down, and a clock rate. And this is going to spit out different gates based on the input. So as you turn this clock rate up, see that flashes, up to audio rate, and back down. Now, I've got an offset patched in that's currently turned down. With the input down, this is just getting this first bit output and there's no other signal present to activate that. Now with this high offset and I turn the input up, notice that we're starting to get these changes and we're actually filling up this digital counter. Now with this input up full, I'm going to turn down the offset voltage that's present at my input. Similar effect to turning that down. Now if we were to use an LFO instead of an offset, this is bipolar, so I'm going to flick the unipolar to bipolar switch and turn this signal up. I'm also going to turn the clock rate up. You can see we're starting to get these different values at the output. So just to get an idea of what this is actually doing, let's plug some inputs in. Turn the clock rate down. So I've now got a triangle LFO plugged in. This has been converted to a digital signal and going into that 8-bit counter. The 4 outputs that I'm taking from steps 2, 5, 6 and 8 are going to trigger envelopes opening VCAs with 4 differently tuned oscillators. At the clock rate set by the module, there's an internal clock and some clock FM that we're going to look at in a second. This is now sampling whatever's in that counter and firing out gates. And unlike a comparator or other similar modules, we can have different outputs present at the same time, not just one or the other. So it's not just converting that raw CV into 8 different steps, we're actually getting this counter that can fire out multiple values at once. Let's turn up the clock rate. Now there is a switch for the rate and we can take this into audio rate. Let's look at adding in an LFO to the FM, turning up the FM amount. Turn down the LFO that's now in the FM. And turn up our bass clock rate. So we can actually FM that internal clock rate as well. But where this gets really cool is if we actually clock the VERT faster than say a clocked LFO. So I'm going to use a clock input now. And notice that this bottom flashing LED cable is the rate that we're actually triggering at. And because I'm clocking the VERT 8 times faster than what I'm clocking this tapped synced LFO at my input, we're getting these repetitive, repeatable patterns from what might seem like a random module. So notice we're getting a repeating pattern. I'm going to change this from a triangle shape to a ramp. Notice that pattern changed. Now back to a triangle. And to a saw. Back to a triangle. Let's try a sine wave. Back to a triangle again. Let's try that ramp. Now, some reverb and delay on there, but you can hear these patterns changing. Now if I mess with the input level, we'll start to get some different responses from the module. One thing to note, which is really useful because you can customize this to just how you want, there's a little trim pot there for the brightness of the LEDs. I've got these fairly bright for the video, and also because the Turing machine next to it has got some really bright LEDs on it. But you can trim these just to how you want. Now this is clocked. Let's have a little jam around on a patch. I've got some drums that I'm going to trigger in the background, which are triggering off the same clock source, so these are in time, and I'm going to jam around with filter and some of the settings in this patch. It's a really great module for creating random modulation if you're clocking this and FMing it from different sources and using some random modulation of the input, but also a really good module for predictable and repeatable patterns that can be really fun playing with that input level and the source signal in sync with the clock rate. Okay, so here's the VERT using a random source as the input as opposed to a clocked LFO and something else that's clocked. I am still using the clock input and keeping these clocked. You can see that I've got the clock input on this bottom LED cable. Now this is being multed into the Turing machine next to it, and I'm taking the Turing machine's output from this cable in the corner to my input. This is currently unlocked, so I'm getting a stream of random voltages. I've got the switch set to unipolar instead of bipolar because that's just not up to positive voltages as opposed to something that's minus and negative voltages. I'm going to have no FM in this particular patch and we're keeping that clocked. And I'm taking these outputs, as I was in the previous part of the video, to trigger 4 different envelopes opening 4 VCAs, this time with square waves and some slightly different tunings on those oscillators. So let's turn up the input level and see what we're getting from that random stream of data at the input. This very well could be some sample and hold modulation, or a Turing machine, or any other random source that's clocked in time with a clock on the VERT. Let's say it's a particular pattern that I like on the Turing machine, I'll lock that. Notice we've now got this repeatable pattern because that Turing machine spitting out the CV is a repeatable pattern as well. Let's play around with the input level, changing the pattern. And we'll go to a different pattern on the Turing machine. Now let's look at changing this clock to something different. So taking out the clock, having taken out the clock, this is going to revert back to its own internal signal, so we can play around with that rate. But for a related signal that's actually different to the clock, let's use the pulses output on that Turing machine. So let's take out step 1's gate, plug this into the clock. So rather than a steady clock, we're using this pulse as a rhythmic trigger pattern, but we're still getting that clocked in-time sequences from the Turing machine. Let's change to a different sequence. Okay, so here's a quick look at using the VERT for some normal drum sounds as opposed to triggering envelopes and oscillators. We've got 2 percussion sounds and a clap being triggered by the VERT, and a bass drum and an offbeat hi-hat just as a background to set the tempo. So again, we've got a clocked LFO, our input. You can see that light flashing on the cable. This is clocked 8 times slower than the clock that's triggering the VERT. So again, these in-sync modulations from the VERT and this in-sync LFO, all in time with these drums that have been triggered. Let's change from a triangle wave to a saw wave and see how that pattern changes. Hear those 3 percussion parts being triggered by the VERT change. Back to a triangle. And to a ramp wave. Triangle. Play around with the input level. And to a ramp wave. Saw wave. Triangle. So you can see this can be really fun for creating these different patterns. And rather than using steady LFOs, a triangle, a saw or a ramp, use some random CV mixed in there, manipulating your CV before it actually hits the VERT. It'll be a really creative way of creating these in-time and synced musical patterns for drums, or something that's a bit more random when you've got this unsynced and running on its own clock, with some different clocks and different random gates firing around the rest of the patch. So let's take a second to listen to this patch. I've got an oscillator playing a pitch sequence going into a VCA with an envelope being triggered by the same sequence, which is just playing in the background. Now we're going to use the VERT audio rate to actually process this and get some bit reduction and sample rate style effects. So I'm going to take my oscillator as the input to the VERT, and I've got 3 different outputs patched into a mixer, which is now going into VCA. So instantly you're hearing this has got a bit of a downsampled and bit crushed effect. This is just the output we're listening to. Turning that down, and this is at maximum clock rate. Here's output 5. And output 1. Nice noisy gritty sound. You can obviously mix those. Just listening to output 8, the cleaner of the lot. Let's change this clock rate. Now we can use FM to get these differing audio effects. Let's turn the FM up. Let's get rid of the FM, turn up the clock rate. Let's to output 1 again. It's got a bit of a sort of broken SID chippy arcade sound, which is really cool. So it makes for a really cool, gritty digital audio processor as well. So I've had a lot of fun with the VERT, both clocked, unclocked, in random situations, more musical situations, both for oscillators and melodic parts for patch as well as drums, and also just mangling audio. You get some really great percussion sounds running a mix of drums through the VERT, maybe mixing that in parallel with a little bit of reverb for a really nice thick and grungy background to some clean drum sounds. As always, hit like and subscribe for more videos every week, and check the Patreon link in the description to see how you can support my channel.